In this lesson, we're going to focus on two big things: expressions and equations. This is also a review from stuff you learned in Algebra 1 and geometry, but we want to focus on knowing what an expression is, knowing what an equation is, and when you see them, knowing how to deal with them. What do you do with an expression? What do you do with an equation? So, thinking back to our rule of 4, remember we have verbal and algebraic. Verbally, an expression is something that has variables or numbers combined, while an equation has variables or numbers combined, but they're equal to some value. So in this one, you would see the equal sign. Here, you would just see the combination. Remember we talked about combination in math? When you combine in math combinations are things like plus and minus, multiplication and division, square roots, squaring, etc. Those are all mathematical combinations. Both of these have those, but only this one has the equal sign. So algebraically, what does this look like? Algebraically, this might be something like 12 plus 3 minus 5. That's an expression. Or something like 2 times x minus 7. That's an expression. The equation is going to be something like 2 times x minus 7 equals 10. There's an equal sign for this. It's worth some value. 12 plus 3 minus 5. If I'm going to put in an equal sign here, I can't just put another number. That's not an equation. An equation must have a variable like x. It is possible for expressions to only be numbers. You can have both variables and numbers in expressions, but an equation must have an equal sign and it must have at least one variable here for it to make sense. What do you do with each of these? Well, for an expression, we want to simplify. That's our big word. With expressions, you simplify. For an equation, we want to know what the variable is actually worth. So we'll say solve. So when you're looking at your directions, that can also be a hint for you. If it says simplify, you're probably dealing with an expression. It says solve, you know you have an equation. Now, when you're solving, do you have to simplify? Would I have to combine these? Absolutely. I'd have to put these together and say 12 plus 3 is 15. 15 minus 5 is 10. I simplified, but what was I doing? I was solving to get x. So in this lesson, because we're going to deal with expressions and equations, we're going to focus on three big things. We're going to focus on simplifying, we're going to focus on solving, we're going to focus on one more thing called evaluating, which comes in on this side of our chart here. So let's practice a little bit with simplifying first. This is going to use your PEMDAS skills. So here we have 4 examples, and notice that these first 2 examples have the exact same numbers. It's the exact same numbers in both of these, but they have different orders of their parentheses and their symbols, and so we'll see what our answers come out to be. Remember, for your PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction. So we'll do our parentheses first. Inside of our parentheses, we have 8 minus 2 squared. Whoops, we have a squared. That's an exponent. Let's take care of that. So we have 8 minus 4. And 8 minus 4 would be positive 4. Now that we know that is, let's put in the rest of our numbers here. 40 plus 24. So we've taken care of the parentheses and the exponents. I don't see any more parentheses or exponents, so we move on to multiplication and division. Remember, we talked about these two things are inverses last time. You can do these together. I don't see any multiplication. I see division. I see 24 divided by 4. 24 divided by 4 is 6. So 40 plus 6 minus 1. We're done with that one. Now I move on to addition, subtraction. 40 plus 6 is 46, minus 1, which is 45. Or we could say 6 minus 1 is 5, 40 plus 5 is 45. Again, those two can go together. So 45. Let's practice another one. We've got lots of parentheses here. So 40 plus 24 is inside parentheses, 64. And then we'll just copy down more parentheses. It's a squared, so 2 squared is 4, minus 1. I have to finish what's inside the parentheses here before I can do anything else. So 4 minus 1 is 3. All right, parentheses are done, exponents are done, multiplication, division. I've got division here. 64 divided by 8 is 8. And then I have my minus 3. 8 minus 3 is 5. So how we do them, what order we go in, does make a difference for our answers. Here's another one where order makes a difference. Negative 6 with a squared, or the quantity negative 6 squared. Here's how I want you to read these ones. I want you to read this one as the opposite of 6 squared. Whereas I want you to read this one as squaring negative 6. This one here is like saying that we have negative 6 times negative 6. It's this quantity squared. A negative times a negative is a positive, and 6 times 6 is 36. So this answer is positive 36. This one, however, the negative's out front, but that's not included in the squared. The only thing included in my squared is the 6. So I have 6 times 6, but I still have that negative in here. So watch out. If you have parentheses or no parentheses, it makes a difference in your answer here as well. So that was practicing our simplifying. Before we move on to our other two, we're going to pause for a quick note here on absolute values, just to help you remember. Absolute value is the distance away from 0 when you have completed all mathematical operations, plus, minus, division, square roots, etc. And the direction does not matter. We simply want to know what's the distance away from 0. It doesn't matter if we're positive or negative. So we are going to simplify and graph. Remember, we have that rule of 4. You give an answer and you do something else, like describe it with a graph, describe it with numbers, describe it with words. So the absolute value of 4, 1, 2, 3, 4, total distance away is still 4. Negative 9.2. 1, 2, 3, 4, 5, 6, 7, 8, 9, and just a little bit more there. That's negative 9.2. What's the distance away? 9.2. So we drop the negative sign. Here's one where we have lots of numbers. 3 minus 8. So 1, 2, 3. But then it's negative 8, so we're going to go backwards. 1, 2, 3, 4, 5, 6, 7, 8. We landed at negative 5, but what is the distance away from 0? Positive 5. So algebraically, we would say that this became 3 minus 8 simplified to negative 5. You drop the negative at the end to become 5. You don't change it here. You wait till you have a single number. So that's a quick review on absolute value, because that's going to come up a little bit later in our lesson here. Okay, we talked about simplifying with PEMDAS, and I said we're going to talk about evaluating and solving. So right now, let's talk about evaluating. To evaluate something means to substitute the numbers given. So here you're given numbers, x equals negative 2, and you're given y equals 5. You'll substitute those for the variables, and then you follow the order of operations. That's just another name for PEMDAS. When we say PEMDAS, we mean following the order of operations. So, anytime you have an evaluate, I'd like you to do this. 7, put a parentheses for that x, minus 3, parentheses for the x, parentheses for the y. And then we'll come back in, and everywhere we saw there was an x, we'll put in negative 2, and everywhere we saw there was a y, okay, But I'd like you to use parentheses when you substitute because we have these negative signs. That's going to help us keep track of when we make it positive or negative. So we've already substituted. Now we follow the order of operations. We don't have anything inside of the parentheses to do. I don't see any exponents. So let's move on to multiplication division. We do have lots of multiplication. 7 times negative 2, negative 14. Negative 3 times negative 2 would be positive 6, and then there's a 5. We still have some more multiplication to do. Negative 14, 6 times 5, positive 30. Okay, now we're done with multiplication, addition, subtraction. Negative 14 plus 30, 16. Let's do another one. Same thing, we're going to use parentheses for our substitutions here. So this has parentheses for the k, minus 18. This parentheses is part of the problem, squared, minus 4 times k again. And k is 6. And now we'll come through and simplify. Inside of our parentheses here, 6 minus 18, negative 12, squared, minus 4. There's nothing to do inside of those parentheses, so it stays a 6. Okay, exponents. Negative 12 squared. Oh, that's like that question we just had with the positives and the negatives here. Remember, this is saying this quantity squared, so this is like saying, think inside your head, this is like thinking negative 12 times negative 12. Negative times a negative is a positive, so 144 positive minus the 4 times the 6. If we run out of room, we'll draw an arrow and come up over here. So now we have 144 minus 4 times 6. Do our multiplication. We have 24. And now our addition, subtraction. 144 minus 24, 120. Okay, you guys are doing great. Let's try one that's a little trickier because it's got a fraction bar in here. 10 parentheses minus 7. Watch out for all your negative signs in here. And then this one we put in a negative 2 and a negative 2. Alright, there's nothing inside the parentheses, there's no exponents. Let's just start with multiplication or division. Now when you have fractions like this, you have to simplify the top of the fraction before you can deal with anything on the bottom. So on the top of the fraction, we'll have 10 times negative 2, which is negative 20 minus 7 all over 3, minus, this one has 8, negative times a negative, so 8 plus 6 over 3. Negative 20 minus 7 is negative 27 over 3, minus 8 plus 6 is 14 over 3. And remember, when you have fractions, they have to have the same denominator. So we're in luck. They're already same denominator here. Negative 27 minus 14, negative 41 thirds. You do not change the denominators when you add or subtract fractions. And this does not go in evenly. So we could say negative 41 thirds, or it goes in negative 13 and 2/3 times. I'm okay with impropers or mixed numbers unless I tell you otherwise. This is okay or this is okay. So that's evaluating. Evaluating is when we substitute something. We take a value and we plug it in. So do we use evaluating with expressions, equations, or both? Think about all the different things we saw up here. Were these expressions, equations? Every single one of the ones we just did was an expression. So far, we've only seen this. If we have an equation, let's think about, like, let's say we had an equation like 2 2x equals 10, and I said let x equal 3. We would have 2 times 3 equals 10, but wait a second, that's 6 equals 10. When does 6 ever equal 10? It doesn't. So I can't just decide what I'm going to plug in if I actually have an equal sign in my equation. It doesn't work. There's only a certain value that works for this x. I can find it, I can solve for it, but I can't just choose something here in my problem. So evaluating is something you're going to see with expressions. You probably, you shouldn't see it with equations, and therefore you won't see it with both. So simplifying, evaluating. Let's talk a little bit more about simplifying here. We have terms and we have coefficients. You've heard these before. Terms are things that are separated by mathematical operations. By mathematical operations. I'm going to abbreviate that. So separated by things like plus, minus, multiplication, division, etc. If you see any of those symbols, then you have terms. So right here we have two terms. Like terms are things that have the same variables and exponents on them. So for example, a like term would be x squared plus x squared. Or you could even have plus 3x squared. How many x squareds do I have? I have 1, 2, plus another 3. So 2 plus 3, I have 5 total. Those are like terms. These are ones that we can combine into a single term. Unlike terms would be something like x squared plus 4x. This does not have the squared on it. It does not have the same power. Or I might have xy plus x squared. This one has a y, this one doesn't. Even if this one had a squared on it, yes, they both have x squareds, but this one is missing the y. That's an unlike term. So another example of a like term over here might be something like xy minus 7xy. They match and they match. Or if I put a 3 on that y, that one also has to have a 3 in order for it to be a like term. Other thing that we've heard about is coefficients. That is always the number right in front. So the coefficient is 7, the coefficient is 3. Just the number parts. Oops, sorry about that. Just the number parts. So we're going to use the idea of like terms to help us as we simplify some more expressions here. How do I know they're expressions? I don't see any equal signs in here at all. So, simplifying. Inside our parentheses, I have an h and a k. Those are not like terms. They do not match. The h and the k are not the same. That's like having the x squared y and the x squared. I can't put them together. So I move on to my next one, exponents. I don't see exponents. So now I'm going to do multiplication, division. I do have multiplication. I've got the 7 here. Do you remember when we talked about distribution? Back in Algebra 1 in geometry, we're going to distribute the 7. So plus 7 times 5h gives us plus 35h. Plus 7 times a negative 4k gives us negative 28k. And we have 2h minus 3k. Combine like terms. So we're going to put the k's together. How many k's do I have total? Negative 3k's plus negative 28k's. I have negative 31k's. Put our h's together. 2h plus 35. Excuse me, 37h minus 31k. So h's and k's can't go together. That's it. That's our simplified expression. We're going to practice some more here. Y's and 1's can't go together, so we're going to start with distribution. Distribute the y. Now, when you have a y times a y, like this, y times y, we say that that's a y squared. There's a little thought bubble for you there. So there's our y squared. Minus 3y squared. when we have a negative in front of parentheses, even though there's no number there, remember, it's like there's a 1 hiding right there. So we're really distributing a negative 1 to all of these. So negative 1y and negative 1 times 1. All right, let's go ahead, let's combine like terms. What do we have? We have some y squareds here that can come together. We have 1y squared minus 3y squared. So we have negative 2y squareds. I have 1y plus negative 1y. These are actually going to cancel then. And then I'm left with negative 1. Oh, here's another little tricky hiding 1 for us here that we got to distribute. Negative 1 times 2x is negative 2x. Negative 1 times y, negative y. Negative 6 times negative 5, positive 30x. Negative 6 times negative 3, plus 18y. Combine our like terms. X's go together. Negative 2x's plus 30x's, 28x's. Negative y plus 18y, 17y's. So that's also simplifying. There's no equal signs in here. So we've talked about simplifying, we've talked about evaluating. Now we're going to talk, in the next part here, we'll talk about how do you solve.